Hello, my name is Eric Martin. I'm a lecturer of mechanical engineering at the University of Maine. Today we're going to look at a tutorial of Mathcad from PTC, and we have Mathcad Express and Mathcad Prime. If you're not familiar with the two, Mathcad Prime is a free 30-day trial that has many tools. Then after 30 days it's scaled back to what's called Mathcad Express, and that is free for life. One more thing to mention is that Mathcad cannot be installed on Mac operating systems. It is only installable on Windows machines. If you don't have Mathcad installed, follow this link or click on the link in the About section. Once you put the information into a web browser, you'll come to PTC Mathcad Express download page. You can enter your information, click Submit, and you'll be brought to the Install Software page, where you can click Install Software and save the file, and you can see your download of Mathcad here, run it, and it will ask you to continue. I will not go on from here as I already have Mathcad installed. Before continuing on with the tutorial, I encourage you to go to my website, which is a Google site, sites.google.com/a/main.edu/Eric_Martin. And on this site we have some engineering tools including PTC Mathcad, and we have a link for the download for Mathcad Express. We also have a link for a systems requirements. And if you'd like to follow along with the tutorial, you can download my practice sheet. This is the file I will be using. So click Download, choose Save File, then look for it in your download folder, and then you'll see Mathcad Intro. I'm going to double click the Mathcad Intro. Mathcad Prime 3.1 is opening up. It usually takes a few moments the first time around. And we can see that we have a worksheet that I put together that we'll be going over throughout this session. Now before I go too far in the worksheet, let me just minimize. I want to just bring your attention to the fact that we have Mathcad Prime 3.1, a shortcut. And if need be, if you can't find Mathcad Prime, sometimes just typing it into your search, and then we can see Mathcad Prime, and those are a couple other ways that we can start Mathcad. Now as we look at Mathcad, we can see that we have several tabs at the top. The first one is our Math tab. Next is Input Output, Functions, and then we can go on to Math Formatting and Text Formatting, and those will be the ones that we'll be using the most. This is our environment, our worksheet. We can right click and turn our grid on and off, or show the grid. Our Math toolbar has operators such as our absolute value, radical signs, exponents. Symbols are also shown here, some of our Greek symbols. And here further down the road we have units, and we'll talk about this a little bit more, as well as our unit systems and our base unit. If you want to change your unit system, you can go from SI to US customary. And Mathcad kind of acts like other Microsoft products where you can cut and paste. You can drag this window, and you can see that I can drag it around. I can also select the window, Control C, and hit Control V, and then there's my window again. I can Control X. I should be able to Control X, and there it's gone. As for our math formatting, we can see that in this tab up here, in our result format drop down, we can change our output to different powers of 10, whether it's scientific or engineering. We can also change the precision of our display. That's it. We have G, which is acceleration due to gravity. We can see we have 9.81 meters per second, and then I can change the number of decimal places that is shown. If I type cm, and it gives me 0.1 meters. If I increase the number of decimal places, I don't see anything happening here, but I can see the decimal places if I show the trailing zeros. The other thing I can do is change the format. If I want to delete these, I can use a little window, press the delete key. Now let's look at text. If I right click, it says I can enter a text block. A text block will span the entire width of my screen, as we see here. This may be too long. Or I can right click and hit enter or insert text box, and it's a little smaller. Another way I can do it, as we see here on the left, is Control Shift T, a little bit harder to do with your fingers. Or just Control T will be a small box. With my text boxes, I could also do some formatting, as we can see here in the text formatting, and we can change either highlight or change text colors. Now the next part is kind of the fun part, getting into the math. And the first thing we're going to do is set variables. And what I'm going to do is I'm going to drag some of this stuff down so we can have room to discuss this. And I will say that Mathcad is a little bit finicky with where everything's located. You can see there's a grid, and even whether we show the grid or not show the grid, we have snapping to the grid. Okay, we have some room cleared out. Let's start entering some variables into Mathcad. We'll start with A, do the shift semicolon or the colon key. That gives us a method to put an input for A, and we'll type in 5. Then we can hit enter. For B, we'll do it again, shift semicolon. Here we'll do maybe a -8, enter. And now for C, we'll do shift semicolon. We'll do A plus B, and nothing seems to have happened. So if we hit C again, we can hit the equals key, and we see that that is equal to -3. If we try D, shift semicolon, how about C squared? So do C caret 2. Now the caret key is this key right up here, right above the 6. And instead of clicking somewhere else or hitting enter, I will actually hit the equal key. And we see the answer is 9, which is -3 squared. Let's try something a little more complex. We can use parentheses. So above the 9 and the 0, the open and close parentheses on most keyboards. So I'll do open parentheses, and I'll do A plus 5. And then what I can do is I can hit the space bar, and when I do that, you may be able to see that it starts to select more and more. And so I've got the entire parentheses selected. I'm going to do the caret again, and I can type the 2 for squared. Now I can use the left and right arrow keys, and even the up and down arrow keys, to move around my expression. What I'd like to do is I'd like to have the whole expression highlighted, so I can do the slash, which will be divided by, and I suppose we can put something like C in there. Now if I press the plus key, I'm still down in my denominator. If I want to backspace out of that, if I want to add the entire expression, again I use my arrow keys, plus, and then maybe let's do a square root. So I may have to come to my Math tab, Operators. I can hover over the square root and nth root. You can see there's also a shortcut, which is the backslash key. I'll just click this button, and here I can put, well, let's do D plus 1 over 5. I'll press the equal key, and we have a value of -30.3. Now if I want to give this a variable name, let's just go with G, shift semicolon, and it's asking me for an input. What I'll do is I will highlight my expression, Control C, go into my red box, Control V, and now G is equal to -30.3. Now here's a good time to mention a few things. The power of Mathcad is that all these expressions, or all my inputs, are variables and I can change. So from 5, maybe I wanted 15. And you can see that everything was updated. One more thing is the equations must come after variables. I cannot put C above A and B. When I do, we realize that B is undefined because it comes after, and that works left to right, top to bottom. So C can come after the B, but it cannot come before it, or the A. I'm going to delete all these terms, and let's talk about units. Let's say we put a variable L for length, make that 5 meters. Then we'll have a variable for depth, D, make that 4 meters. We can have the area is equal to L times D. We see that we have 20 meters squared. If we change it from 50 meters, again, our area updates. Perhaps we have a height that is 10 inches, so it'll be 10 times IN. Well, our volume can equal our area times our height. And even though our area is in meters squared and our height is in inches, when I hit the equal sign, we have liters. Now, right now we are in our SI system. We also have the US system, and we can click and see all the different units that we may have. And I can overwrite the liters. Let's go cubed, millimeters cubed. Again, it accepts that. But I can also change it to inches cubed, as we see here. If we want to know our velocity, and I guess I just use v, so I'll use little v for our velocity. We can make that, we'll say our distance divided by 4 seconds. But we can see we actually have 1 meter per second. Okay, I've cleared up our workspace, and we can now talk about units of force, stress, and pressure, and mass. So let's type force. Let's make that 10 kilonewtons. When I type force again is equal to something, we have newtons, but let's say we want this to be in pounds. So I'll type LB, and I get this weird thing that's happening, and what we see is that pound LB is actually a unit of mass, and then we have mass times our acceleration. In Mathcad, we have to type LBF, and sometimes it gives us a little bit of junk like this, and so we should just highlight the whole thing, type LBF all over it, hit enter, and now we can see that in pounds force. We can also change this to KIP, K-I-P, which is kilopounds, and we can see it looking just like that. Mass, if we make this to be 12 kilograms, and hit the equal sign, it'll be typed right into kilograms, and I can overwrite that with LB this time because LB is a unit of mass in Mathcad. So LB is mass, and LBF is pound force. If we'd like to have stress, stress is equal to our force divided by area. I think we have to change my area up here, but let's just type that in for now. Actually, let's type equal and see what we're at. We're at 50 pascals. But let's bring this to 50 millimeters and 4 millimeters. And so we have pascals. We can make this into kilopascals. We can even write stress is equal to, and we can do this in PSI, which is pound force per square inch, and KSI, which is kips per square inch. So very handy. Moving to Greek letters and symbols, these are simply done by pressing the Control G after a letter is keyed in. So if you do uppercase S, Control G, I get the uppercase sigma. Lowercase s, Control G, lowercase sigma. Other interesting ones are the Y, I believe that would be psi. Q, as it's shown here, is theta. If I accidentally press Control G, I can press it again, and that'll bring me back to my original letter. The next segment is subscripts and superscripts, which would probably be better stated as exponents. And for our exponents, we've shown this already, so if I do 4 cubed, that would be 64. Again, there's a caret sign. For subscripts, I use the Control underscore button, kind of a handful with your hands. But let's say do sigma, which would be S, Control G. I now press the Control underscore, and we can see how the cursor went down a little bit. Maybe I have average for our average stress. I can do V max for our maximum velocity, or whatever we may choose. I just want to mention that it does take some practice to become familiar with how Mathcad handles its parentheses and fractions and divisions and exponents and so on and so forth. Let's say we had just had a simple equation where we had a rectangular beam that had a base of 4 inches, had a height of 10 inches, that's just a cross section, and maybe we had a vertical shear force acting on it of 500 kip, and we, let's see, we have a distance from our centroid. We'll say we want to investigate at 3 inches. If we were to look at our equation for our shear stress in a beam, we see that that's tau, which would be T Control G, and that's equal to 6. And here we don't need to do the multiplication sign. We're just going to do a capital V, and it assumes that it's there already. Then we want to have this all over BH cubed. So we're going to hit the spacebar 2 times, slash B. And now I do need to type in the multiplication sign, because if I don't, then BH will be one variable. So I do need to do B times H cubed, hit the spacebar a couple times, or again we can use our arrow key depending on where we're at. Then we'll do open parentheses, and again it inserts or implies a multiplication sign, and I think this would be H squared. Oops, there we go. I hit the space bar because I want it to be all over the H, not just the 2 in the exponent. Divided by 4, and then I want to subtract y squared. The tau Control G, or T Control G, is equal to 827 times 10 to the 7th pascals. Let's turn that to KSI, and we see that's 12 KSI. So again, it does take some time. It just needs a little bit of practice, but it will come. So Mathcad does also handle units for angles fairly nicely. It does consider its basic unit is the radian, but it does also understand degrees either as a symbol or DEG, as well as revolutions, REV, and pi. For pi, it's P Control G, and I'll hit the equal sign. Oh, actually, let's do this. Let's go P is equal, and it'll probably give me an error because it doesn't know what P is. But if I do P Control G and hit equal, then we can see that it's equal to 3.14. We can see that, let's say alpha, which would be A Control G, is equal to 180, and we can either type degree, or we can go hunt for the degree symbol, which is under units right here, 180 degrees. I can see that alpha is equal, and I didn't use the Control G. Alpha is equal to 3.14. Again, it assumes radians, which is pi, but maybe I want to know what it is in revolution. That would be 0.5 revolution. So now let's look at some trigonomic functions. Mathcad handles sine, cosine, tangent, arcsine, cosine, and arctangent as well. Let's say that beta control G, or B control G, is equal to, let's use 60 degrees. Then we could have sine beta, and that's equal to 0.87. Please understand that when you do sine and then open parentheses, if you just type in 60, it's going to assume that you mean 60 radians, not 60 degrees. And so you have to put the units in when you're not dealing with radians. You can also do squares. So you have sine, open parentheses, B, control G, and we bring our cursor outside the parentheses, and then plus cosine, open parentheses, B, control G for beta. Bring the cursor outside the parentheses to do a square. This should give us a value of 1. Okay, let's look at plots. We'll come into our plot tab, insert plot. We'll use a XY plot. And one of the things that we want to be careful of is that the axis, or the label here next to our x-axis, is actually our label for our y-axis. Here's our x-axis, and here let's just use y, control G for psi, and then for our y-axis we'll do sine of y, control G, and it should make a nice sine wave. And do cosine, and that should be a cosine. So that's about it for our tutorial in Mathcad. If you have any questions, please be sure to fill in the comments below. Thank you for watching.